They were letting this off the whole game. That's a 50. It's just like
Okay, let's start our lecture today. Hello, everyone. Today we will complete our previous topic about IP addressing. Today we will discuss the IP subnetting. Let's make quick revision about the IP classes. As we discussed in our previous lecture, that we divide the range of IP addresses into class A, class B, class C, class D, class E. The difference between each class is that each class has different network portion and host portion. For example, in class A, this is the IP address. Consists from 4 octets. Each octet 8 bits. So the total 32 bits. In class A, the first octet is assigned to network part only, and the other 3 octets is allocated to host part. Okay, so if we want to see the subnet mask for class A, in the subnet mask, the network part is 1s and the host part is 0s. Okay, so 1, 2, 3, 4, 5. Okay, so here we can write the subnet mask of class A in decimal as 255.0.0.0. Another way to write the subnet mask is to count the number of ones in the subnet mask. How many ones here in this subnet mask? 8. So you can write the subnet mask as /8. Okay, instead of writing 255.0.0.0, you can write only /8. So I will understand that we have sequence of 8 ones followed by 24 zeros. Okay, so the number of hosts that class A can support is number of hosts is equal to 2 power number of bits allocated to the host part, which is 24, and we subtract 2. Why we subtract 2?
well, one is the network address, and then for like broadcasting.
Yes, so we serve one IP to the network address. It is the family name. No one can take the family name, okay? And the last one is reserved for broadcast address. If I want to broadcast a message to all of you in this class, I will use the broadcast address. So the number of the hosts can one range from class A serve is around 16 million devices. And when I say one range in class A, for example, if I start from 10.0.0.0, it will continue till 10.255.255.255. Okay, so we will change from 0 to 255. After that, we'll increment this by 1, and it change from 1 to 255. And after that, we'll increment this from 1 to 255. Okay, so hello. Yes.
Sorry. So when you're saying like, okay, like the family name, we don't want the network IP to be the same as the host IP. So like in that situation, like you just did, so 10.255.255.255, you wouldn't want your IP to be 10.10.10.10 because that just practice or?
Okay, so here in this range, our network address will be 10.0.0.0. This is the network address, okay? And our broadcast address will be the last address in this range, which will be 10.255.255.255. Any IP address in between in this range can be used to any host in the network, okay? But we can't use this IP address and this IP address. So here I will start from 0.10.0.0.10.255. After that, I will increment this by 1, okay? So 10.0.1.0, and I will still increment to 25, and after that this will be 2, and go on through all of these octets until I reach to 10.255.255.255. So any IP in between I can use for the host. Okay, but the first one and the last one I can't use. Reserve it for network address, family name. No one can take. This is our family name. No one can take this IP, and no one can take the last IP. Okay. Okay. For class B, the difference is that the first 2 octets are allocated to the network, and the last 2 octets are allocated to the host. Okay. So the number of ones here in the subnet mask is in class B 16. So I can write the mask as /16. Okay, and number of hosts 2 power 16 minus 2 can support around 65,000 hosts. For class C, the first 3 octets are allocated to the network part, and the last octet is allocated to the host part. Okay, so number of ones here 3 multiplied by 8 equal to 24. So we can write the mask as /24. Okay, and the number of hosts is 2 power 8 minus 2. So it can support 254 devices. So we can use it for small networks. And we have class D, it's used for multicast transmission, and class E is reserved for research development. Okay, this was a revision about IP classes. Now, as you can see here, if I have a network, this is sales network, and we have some device around 20 devices, and we have other network around 10 devices, HR for example. Okay, and this is a router. Okay, you are the network administrator, and the company asked you to please design a network for us, and you are now in the step of assigning IP addresses to different networks. Okay, what should you do in this case? You have 2 networks in your company, and each network must have its own network address, broadcast address, range of IPs address. Okay, so in this case, you have in the first one 20 device, and the second one you have 10 device. So you are going to IANA. IANA is the organization responsible for IP addresses, and you want to buy range of IP address. From which class you will buy? You have some IPs from class A, some IPs from class B, some IPs from class C. You will buy from which class? C.
I would think A, but I feel like I have no idea.
A, okay. It's just discussion. B?
One of those. A, B, C, D.
No. Okay, you have 3 pools, class A, class B, class C, and you want to buy. You will for sure. Class A can support 16 million devices, so its price will be very high. Class B will support around 65,000 devices for intermediate networks. Class C can support up to 254 devices.
Oh, nice.
So you will buy from class C. How many IP ranges you will buy? One class C IP range, or two class C IP range? Two. One for this network and one for this network. That's perfect. Okay. So in this case, you will buy one class C IP range that can support 254 devices to serve only 20 devices. And you will buy another IP, class C IP range to serve only 10 devices. So you have now IP range that can serve 254 devices to serve only 10 devices. Actually, using classful addresses, we are wasting our IP addresses. So in this case, you will use only 20 and you will waste around 234 IP address. And in this case, you will use only 10 and you will waste about 244. Okay, so using classful IP addresses, we are wasting our resources and we are paying more. In our case, when you are going to IANA, you will pay for 2 class C IP addresses. Okay, so you will pay for the first one and for the second one. So you are wasting IP addresses and it is additional cost for you. Okay.
Is that actually like how it will work? Like, do you actually buy all 255 of every network range? It seems like you would waste, like we would run out of IP addresses very quickly. That was the case.
What we actually do in real life, you will see now. Okay, so we don't buy 2 class C IP addresses to serve these 2 networks. No, for sure we will not do this. Okay, but what we will do, we will use the IP subnetting. Okay, what is the meaning of IP subnetting? IP subnetting allow us to create multiple logical networks that exist within single class A, B, or C IP network. So in this case, instead of having 2 class C IP addresses, we will buy for only 1 class C IP address range. So we will only buy 1 class C IP address range. And we will make logical subnetting to allow to have 2 subnetworks under the main network. Okay, so at the end, you will have 2 logical subnetworks. This will be separate network from this separate network using the same IP range. How can we do it? We will see in the next slides. So IP subnetting allows us to divide our larger network into smaller network. So in this case, if we use classful addressing and we buy only 1 class C IP range, and we will allocate the IP addresses to the devices in these 2 networks. Using classful addressing, this network will be considered in the same network with this network. So these 2 networks will be considered as 1 network, as they have 1 network address and 1 broadcast address. Okay, so these 2 networks will be as 1 network. Okay, so this is good for the security of the network. For example, if you are designing a communication network, or you are here at the campus, we have financial department, HR department, accounting department, engineering department. Is this good for the security that all of these departments communicate within one network, or make separate network for the engineering, make separate network for the HR, make separate network for the sales? I think that to make it better for the network security and network management, to make separate network for each department. I am in engineering department. I don't care about what happened in the HR. Yes, okay, and I don't care about what happened in the sales. I only care about my supervisors, from the mails coming from the engineering. For sure, I care with the HR, okay, at some minutes, okay, but not all. In the all messages sent from the HR, I don't care from all of these messages. Okay, so it's better to make separate departments, okay, to better manage these networks and for the security. Okay, maybe there is one hacker in the engineering department. Okay, so the engineering department will be only the affected department by this hacker. But if we are all in one network, the hacker can have access to all other departments. Okay, so to manage your network in efficient way, it's better to make separate subnetworks. Okay, so the benefit of IP subnetting is allow you to divide your large network into a smaller network. This provides us with better management and improve the network security. Okay, what if we don't have subnetting? If we don't have subnetting, we will have the problems that we discussed now. We are only able to use one network from your class A and B or C network IP range, which is unrealistic. So in our case here, in order to design this network, we will have two IP ranges from class C. So we are wasting the IP addresses and we are wasting our resources. Our resources here means host, IP range. This is our resources, okay? So the main benefit of subnetting is allow us to create multiple logical subnetworks under the same main network, okay? This is the benefit of IP subnetting. Actually, we have two types of IP subnetting. We have fixed length subnet mask and variable length subnet mask. In fixed length subnet mask, it allows us to divide our main network into some subnets. Each subnet has equal size and equal number of hosts. So, for example, here, if we have this is third network and another fourth network. Okay, so using fixed length subnet mask, we will divide the 254 IP in equal between these four subnet masks. So each subnet will take around 62 IP address. Okay, so all subnets are of equal size with an equal number of hosts. This is called fixed length subnet mask. Okay.
Could you not just have an equal, like, if, for example, since our max number is 20, could we just have equal everyone has 20? Does it have to be like an equal division of the max?
Yeah. In fixed length subnet mask, okay. Actually, we here you have 20 devices, for example, and this 10 device. I will allocate to this department the same number of IP address as I will allocate to this network. No matter the number of devices here and number of devices here. That only one thing that I should pay attention for it is the allocated IP addresses must be equal or greater than the number of devices served by this network. For example, I can't, if you have 20 devices, I can't allocate to you 10 IP addresses. what happened if 10 will be connected and other 10 users will be blocked? They don't have any IP addresses. Okay, so in designing your network, you should pay attention to the number of hosts, or if you want to allocate IP addresses, you should allocate number of IP addresses equal or greater. Okay, if the number of IP addresses greater than the number of hosts, okay, I waste resources, okay, but at the end, all the users are connected, okay. But if the number of IP addresses is less than the number of hosts, not all of users will be connected. Will increase the block rate on my network, and this is not good for your design, okay. So for fixed length, it will allocate equal number of IP addresses for each subnetwork in your main network, okay? Okay, but this is not efficient. So in this example, the number of IP addresses that's allocated to this network that has 20 devices will be the same as the number of IP addresses allocated to this network that has only 10 devices. This is efficient, not efficient, okay? So the second type of IP subnetting is using variable length subnet mask. Different subnets can be of different sizes. So I will allocate to each subnet number of IPs, okay, matched with the number of hosts. So for sure, I will allocate to this network more IP addresses as compared to this network. And this will be, I think, more efficient. I will use my IP addresses more efficiently. If the network that has more number of hosts, more number of devices, will be allocated more number of IP addresses. The network that has minimum number of hosts will be allocated minimum number of IP addresses. Okay, and this logic. Okay, okay. Let's see how we can implement fixed length subnet mask and variable length subnet mask to make IP subnetting. Okay. Actually, subnetting can be done by changing the number of ones in the subnet mask. Okay, so for example, till now everything is clear. Everything is clear to you. Okay, that's good. IP subnetting is one of the important topics.
What's like the rule of thumb? If you're a 20 device network, when you allocate 30 IP addresses for your case, you know, like I don't know if people have smartphones connected at random times or.
Okay, I mean by device, not persons.
Yeah, I know.
I mean devices that include your laptop, your mobile phone. If I design the financial department network, I know that in the financial department network, I will have for around, for example, 20 desktop devices. Okay, this is my network. Okay, actually, if you want to connect through your mobile phone, your personal item, okay, mobile phone, iPad, for security issue, you will be connected to the public network of the company, not to the private network of the financial department. As while you are using your mobile phone, you may access to your Facebook, for example, other websites that may have some security issues. So if you have access to these networks through the private network, okay, you may bring hacker, something like that, okay? So it's as a security issue, while you are in the company, okay, the private network for the department, not for use for your personal browsing, for example. If you want to connect through your mobile phone, you will be connected to the public network. It is the same here at UBC. You are connected to UBC secure, something like that, okay? But each department has its own private network, okay? So this is the basic idea. So in the design, You are the engineer, okay? So you design the for financial, you know how many PCs, personal computers or desktop computers will be installed in this lab. So I will design to serve only these personal computers. Other devices will be connected to the public network, okay?
So you don't allow any sort of like leeway on laptops that could.
Yeah. No way, okay? So most of these departments, network of these departments are connected via wired cables, not using Wi-Fi, okay? So it is through wired cables to ensure that the device that's connected to the cable is only connected to our network, okay? Okay, so how can we make IP subnetting? Through using, through a change in the number of ones in the subnet mask. For example, here in class C IP address, the default subnet mask is in class C to 0/24, okay, /24. So the number of devices is 2^8 minus 2, which equal 254. What if 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5. Okay. 0, 0, 0, 0, 0, 0, 0, 0. This is the subnet mask of the class C. What if I change this 0 and then make it 1? Okay, so this will be the network part, okay, and this will be the host part. So our subnet mask now will be /25, and number of hosts that can be served by this IP range will be 2^7, yes, minus 2, which will equal 126 devices. Okay, so by changing the number of ones of the subnet mask, I can minimize the number of supported hosts. Okay, so let's see. In this example, we have IP address, and its mask is /26. So we change it. These two IPs from 0 to 1. This is given to you. Okay. The first question: what is the class of this IP address? Class C. Class C. Okay. Second question: how many subnetworks can be supported by using this new mask?
252. 262.
62 subnet network? No.
Like how many subnetworks can be within that subnetwork?
Yes.
Like 200.
Actually, the answer will be, in order to calculate it, we must first calculate the difference between the new subnet mask and the default subnet mask. The new subnet mask here is 26, okay? And the default subnet mask is 24. So the difference is only 2 bits, okay? So the number of subnets can be supported by the new subnet mask will equal 2^2, which will equal 4 subnets, okay? Which will equal 4 subnets. Let's try it. I have my range. For my range, okay, I have the default 1.0/24. I can serve only 254 devices. Okay, now I have new subnet mask /26. How many bits for the host? Yes. as we have the the subnet mask is 32 bits minus 26 will be 6 bits. So how many hosts can be supported by this IP address? 2 minus 2, which will equal 62. Okay, so okay, if you want to divide, try to do it. Okay, divide this number by this number. What will be the result? Four. Approximately 4. Yes. You tried it? No. Okay. Anyone try to calculate it?
-6, 248.
Okay, approximately 4 networks. Okay, 4 networks. Okay, so how we can calculate it? Okay, you can calculate it through this way, or you can say my new subnet mask is 26 and my default subnet mask is 24. So I changed only 2 bits in the default subnet mask. So number of subnetworks that I can serve is 2 power the 2 bits will equal 4 subnet networks. So you can serve 4 subnet networks by changing the default mask from /24 to /26. Okay. How many valid hosts per each subnet? We already calculated it. 2 power 6 minus 2 will equal 62 hosts. Is this clear for you? Okay.
I had a question for the first time. How did you convert the IP network address to all those ones?
Yeah, this is from decimal to binary.
Oh,
Okay. Okay, so now I will arrange my IP addresses. So I will start from the first IP. Okay, this is my first IP in the network. It will be the network IP address for the first subnet. Okay, if I want to know what is the network address for the second IP network, what should I do? I have my network. Okay, it consists of one IP address for the network part, for the network address, and one IP address for the broadcast. Okay, and 62 devices. So how many IPs in this network? 64. Okay, so if I want to know the network IP address for the second subnet mask, I must add 64 to the first IP address. Okay, so the network IP address for the second network will be 1.64. If I want to know the network IP address for the third subnet, what should I do? Add 64. Okay, so it will be 1.128. Okay, if I want to know the IP address of the fourth subnet mask, I will add 64. So this will be the network IP address for the fourth subnet. Okay, now I want to know the broadcast address for the first subnet. What should I do? Okay, can you say, increase your voice? Okay.
Oh, subtract 1 from the network.
Okay. The broadcast address is the last IP address. Okay, so I know now that the network IP address for the second network. So I will subtract 1 from this network. So it will be 1.63. Okay, here the broadcast address of the second network. Okay, so it will be 127. Here, subtract 1, it will be 191. Okay, and here, if we add the another 64, it will be the last IP address in the range. So as you can see here, we start in the default, the network address is this IP and the broadcast address is this IP. But using subnetting, we now can, using the same classful IP range, we can serve 4 networks instead of 1. Okay, so 4 networks instead of 1. So we can now use our IP in an efficient way. Okay, and each network will have network IP address and its broadcast address. And the IP addresses between 0 and 63 will be the valid IP addresses to 62 device. So from 1 to 62 will be allocated to your devices. Okay, this is clear for you? Anyone has any question? Anything not clear? Okay. Okay. Okay, so now we studied the case of /26. Okay. Okay, and I want to take your opinion in order to save our time. Okay. We have another example for fixed length subnet mask. Okay. It will follow the same way. Okay. I can explain it again for you to make you understand it more, or we can start at the variable length subnet mask. Okay. It's up to you. We can make variable length subnet mask in the next lecture if you want. Okay. Let's see based on the available time. Okay. Okay. So here, as you can see, if our network is /24, which is the default, okay, we can only serve 1 network. Okay. As if you use our method, okay, the new subnet mask is 24 and the default subnet mask is 24. So the difference between them is 0. 2 power 0 is 1. So I can serve 1 network only. And the number of devices in this network, 2 power 8 minus 2 is 254. This is the default case in class C. Yes. If we make the subnet mask /25, so what is the difference between the default subnet mask and then the new subnet mask?
The new subnet mask has a 1 significant bit of the last one.
Okay, so we increase the subnet mask by 1. Yeah, so I have now 25 instead of 24. Yes, so the number of subnets increased by 2 power 1. So I can have 2 subnets. Okay, and each subnet can serve 126. Okay.
If you were serving a IP address for 1 singular device and you knew that there would never be any chance of another device, you technically go to /31 and just have your only 2 addresses as the broadcasting in the network.
Your question is that I can serve only 1 device in the network?
Yeah, like could you go, because obviously this ends at /31.
Yeah. I can continue in /31. Yeah.
If you only have 1.
Okay. Yeah. Okay. So, but
It would only have broadcasting on the network IP. It wouldn't have.
Okay. In this case, okay, yeah, I know that in your network you have only 1 device, okay, and you still need 1 IP for the network and 1 IP for the broadcast. So you need 3 IP addresses, okay.
So you wouldn't be able to run.
You will. I will not be able to allocate to you 3 IP addresses. I can allocate to you 4.
How come you would need another IP though if you only had 1 device? Like couldn't technically your network IP be your device?
I know. I at the end I will waste the 1 IP addresses. Okay, but it is better from wasting 253. Okay, so I minimize the number of wasted IP addresses. So I can provide you with multipliers the power of 2. I can support you with 2 IPs, 4, 8, 16, 32, 64, and so on. Okay, so it's better for me to serve 1 user and waste 1 IP addresses better from not serving this user. Yes. Okay. So as you can see here, okay.
If you only have 1 device, wouldn't the broadcast IP also just basically function as a?
Yeah.
first one.
Yes, as it is a protocol. It is a protocol. Yeah, we are dealing with machines. Okay, so I must provide them with one protocol. Okay, and they will apply it. Okay, so in this case, you have only one IP address, but the protocol of IP addressing is to allocate one IP for the network and one IP for the broadcast, and between them is the IPs for the host. Okay, so I know, understand, and this is a good question, and it may be a good idea, okay, to optimize the number of hosted IP addresses. Okay, so that's good. Okay, but in practical, we still need to have a broadcast address, one network address. Okay, so in this case, I can't allocate to you three IP addresses. I can allocate to you two IP addresses, 4, 8, 16, and you want only 3 IP addresses. Select. If you select the 2 options, so one IP will be the network part, and one IP will be for the broadcast IP. In this case, it can work. Yeah, as you only have one device, and we will use the broadcast address, and it will reach to this device. Okay, but this, yeah, okay, yeah, but yeah, it can be done in this way. You can use the network IP address and the broadcast address, as you have only one IP address. Okay, but again, there is no network with one device. I can prove it to you. Okay, so let's prove it. Okay, this is a network. Actually, we don't need to have switch, as it is only one device. Okay, so this is your device. Okay, this is your device, and this is your network. Okay, and there is other networks. How can you communicate with other devices and other networks?
Through
Router. And if I have a router, I must be connected to this router. Okay. Okay. And this network also must be connected to this router, or connected to second router, and these 2 routers connected together. Okay. So how many IPs I need in this network? 1.
You need 2.
2. As router interface must take IP address. Okay.
Would not be a way to have your router as the one data and have an internal directory that would take any data from your router to your device?
Sometimes you need to communicate with the router. Okay, so if I want to communicate to the router must have destination IP address. Okay, so the router must have IP. So here in this network, the number of IPs that I need, 2 IP addresses, and I will need network address and the broadcast address, so another 2, so the total will be 4. So in no case you will not have any case that you will serve only one device, as the router interface is considered as a device. Okay, so the minimum network that you may have is 2 devices. Okay, you got it. So you need network IP address, 2 IP addresses, one for the router, one for the PC, and the last one for the broadcast address. Okay. Okay. Let's take the option of /28. Okay. In /28, okay, what is the difference between the new mask and the default mask? We have the new mask is /28, and the default mask was 24. So 4 bits different. Okay. So the number of subnets that can I serve using, remember, we are in fixed length subnet mask. Using fixed length subnet mask, the number of subnets 2^4, so we can serve 16 network. And what is the number of hosts per each subnet? 2 power 4 minus 2, 14 device per each net. And so on, okay? So this is the table that you can create for yourself for class C. Following the same way, you can do your own table for class B. You start by /16 and go on, okay? Try to do it by yourself at home, okay? So this is an example for another example for fixed length subnet mask, but using class B address. So this IP address is in class B, okay? And in class B, the default subnet mask, we have, this is the new subnet mask that can, if we convert it to binary, it will be equal to /17. So the difference between the new subnet mask and the default subnet mask, 17 minus 16 is only 1, okay? So the number of subnets that we can serve, 2 power 1 subnets, okay? So we can serve 2 subnets. And the number of hosts is, we have 15 bits for the host, so 2 power 15 minus 2, so you can serve 32,000 hosts per each subnet, okay? This is an example for the fixed length subnet mask, okay? In the next lecture, we will discuss together the variable length subnet mask, okay? We still have 5 minutes to 8:15, so we can discuss that IP addresses can be allocated static IP addressing and dynamic IP addressing, okay? In most cases, we are allocated IP addresses using the dynamic IP address. When you are connected to this Wi-Fi network, you will get your IP address in dynamic way, okay? But in some cases, we still need the static IP address. For example, if we have a printer and this printer is shared in this department, okay? And I want to print one file. So I must know the IP address of this printer. So as I will send request, I will send my document to this printer to be printed, okay? So the IP address of the printer must be static, not changing, okay? If the IP address is dynamic, is it changing? When you are connected now, you will receive IP address, you will shut down your laptop and return again. Tomorrow, you will receive another IP address. This is what we will have using the dynamic IP addresses. But in static, it is fixed. So some services require static IP addressing, such as printers, servers. Okay, if we are communicating with certain web server or mail server, the IP address must be static. Okay, and how we can allocate static IP addressing? It will be in manual way. I will go to the properties of this device in the TCP over IP properties of this device, and I will say you have 2 options, automatic or manual. I will select the manual and I will enter the IP address, subnet mask, the default gateway, manual. Okay, in manual way. But disadvantage of this method is it is time consuming. What if I have 50 devices? I have to allocate to them static IP address by hand. So it is time consuming. So, but still we need this this way in some services such as the printer server, for example. Okay, but in for hosts, we use dynamic IP addressing. We can use dynamic IP addressing using dynamic host configuration protocol. Actually, there is a server called DHCP, Dynamic Host Configuration Protocol. This server has pool of IP addresses, and it will allocate IP addresses to each device connected to this network. So this is your device. It will send discover message to search for DHCP server. This DHCP server will offer to you, you can take this IP address. So you send acknowledge message to the server. Yes, I will take this IP address. So the server will provide you acknowledgement Okay, this IP address is allocated to you. When you shut down your laptop, this IP address will return back to this server, okay, and it can be used by another user. This is the way that we can actually that we use here in this network and on most of networks, using dynamic host configuration protocol server that is used to automatic allocate to each user connected to the network, allocate to you IP address, subnet mask, default gateway. Okay, this is clear for you? Okay, so in the next lecture, we will cover the variable length subnet mask. Okay, that's perfect. And if anyone has any question, tomorrow my office hours will be from 12 to 2 p.m. Okay, in the 4th floor in EME building. Okay, the number of the office I don't remember. Yeah, but I think it is 4263. Yeah. So if anyone has any question, you can come to ask me during my office hours. You can connect to me through Zoom if you want. You can send me an email. So see you in the next lecture. Okay, bye.